Hey, what's up everybody? This is going to be the start of a new unit, Unit 2, where we're focusing on the foundations of geometry. The very first lesson that we're going to look at talks about the basics of geometry, segment addition postulate, and also an angle addition postulate. We're going to break this down into 3 videos, first focusing on the basics of geometry. With this lesson, at the end of it, you should be able to define these terms: points, lines, segments, and rays, and then also be able to name them using the specific notation that we're going to look at. Also, once we get to the segment and angle addition postulates, you should be able to know how to use those to solve the problems. This picture on the right is just an example of some geometric figures, which is why I included it on this slide. So let's go ahead and get started. So first we're going to look at basic building blocks of geometry. So these are going to be your points, lines, segments, rays, and angles. First, so all of this goes back to ancient Greece. There was this guy named Euclid who was trying to basically put together this whole new subject of geometry. He came up with this idea that he's going to call a point is just an indicator of a location. So what we've looked at is points on coordinate planes. So when we graph these, we usually include like the labels here. But in this case, a point is just a location. It has no size. Now, Euclid also said that we could have something called a line, where if you have 2 different points, you could have basically this line that extends through both of these points here. But in reality, it's an infinite number of points that continues on a straight path that goes on forever in both directions, opposite ways. So the way that we name lines, you should be able to notice here, is usually with double arrows. So both of these have double arrows, and you use 2 of the points that fall on the line. So in this case, K and P are on the line, so we would call this line KP with the double arrows. Or you could go the opposite direction and call it PK with the double arrows. Lines can also be named with whatever like lowercase cursive letter is next to the line. In this case, this is a lowercase cursive L, so we could also name this line with that lowercase cursive L as well. And then plane is also a term that was created by this guy named Euclid, this ancient Greek. And a plane is just a flat surface that extends infinitely and has no thickness. The plane that we should be most familiar with is the coordinate plane. You could also think of a plane as like your desk at school, maybe your table at home if you have a kitchen table or whatnot, but any really flat surface. But again, we're going to keep in mind that extends forever and it has like no thickness. But coordinate plane is the most prominent one that we use. All right, and then we also have segments. So a segment is just a piece of a line. So notice how this looks pretty similar to what we had in the last slide, but now we have like this end's cut off so it doesn't extend in this direction, and then same with the other one. So what you do is you take a line and you cut the ends off it at 2 specific points, K and P. So it has 2 endpoints, and the way that we label segments are just with like a little bar above them. So we'd call this segment KP, just a little line above the 2 letters, or segment PK. Now, we also have what are called rays. So a ray is a part of a line with 1 endpoint, and then it extends in one direction forever. So in this case, we're starting at this point M, and then we're extending through this other point N, but carrying on in this direction forever. The way that we would name this ray is MN, with just 1 arrow above it indicating that it goes in that direction forever. Now, if this ray started at N and went through M and continued in that direction, then we would just label this NM and then still have the ray going the same way. And then we have angles. So angles might be one of the most important pieces of geometry. Angles are formed by 2 rays that share an endpoint. So this diagram right here, we have this ray BA that goes in that direction, and then this ray right here, BC, that goes in this direction. But these 2 rays both meet, or they share this endpoint at B. Now, this naming system right here is extremely important, so don't fast forward through this. So the way that we would name this angle is with the shared endpoint, wherever that is, that letter should go in the middle. That's basically what you need to remember. So we could label or name this angle as angle ABC. Also notice that it has a little angle kind of symbol right in front of it. So we could call this angle ABC, we could call it angle CBA, but again, basically where the angle is formed or where the endpoint that two rays share is, that's the letter that goes in the middle. Now, whenever we have a diagram where there's only like one angle, you could also name it by just using where the angle is formed. So we could call this angle B if we wanted to. And then if there's a number where the angle is, you could also label it angle 1. But keep in mind that we're probably going to use predominantly this 3-letter naming system where the shared endpoint or where the angle is formed is always the letter that goes in the middle. All right, so now we're just going to look at how it all comes together. So this particular problem is pretty similar to the first few. Problems 1 through 6 you should be able to do after kind of watching this first video. But this diagram, labeling points, we got points F, G, and H. If we're going to talk about lines, lines would be basically, again, extending in both directions forever, and it should have this double arrow above basically 2 letters. So FG, this line should extend both forever. F to H would be another appropriate way to name this line. H to F, so write the letters in opposite order. H to G, as long as it has the double arrows above that, it's indicating that you're talking about the line that goes on forever in both directions. Segments. So again, segments are just pieces of a line. So G to F is just this segment right here. It could also mean F to G is the same segment, but just labeled differently, named differently. F to H would be from F all the way to H, this segment in between here, which would include point G. And then H to G would also be a segment. Rays, again, are just the arrows that go in one direction. So G to H would be we're starting at this G, going to H, and off in the direction to the right forever. G to F would be starting at G and going to the left forever through F. And then angle. So angle might not actually be easily identified, but in this case, we have this shared endpoint at G, where if we go G through F, this is a ray that extends into the left forever, and G through H is an array that extends to the right forever. So whenever 2 rays share the same endpoint, they form an angle. So in this case, we're talking about this angle right here. It's an angle that would be 180 degrees. One way to think about this is that if I started at point F and I went around in a full circle, that would be 360 degrees. So what I'm doing is really going in a half circle, so that's 180 because it's 360 divided by 2. All right, you should be able to grasp most of this stuff to do problems 1 through 6. Those are the basic building blocks of geometry, and we're going to continue to build on those throughout the unit and throughout the course. If you need to rewatch this video again, it should allow you to complete questions 1 through 6 on the assignment. We're going to take a break in this video and then come back with segments in the segment addition postulate.